Good evening, class. Today we're going to continue the topic on first chapter, some basic concepts of chemistry. Now, last class we completed empirical formula and molecular formula. I'll be doing more problems on empirical formula and molecular formula in the coming classes. So now what we have to study is a very important topic, stoichiometry. Stoichiometry and stoichiometric calculations. Okay, so what is basically stoichiometry? In normal language, if I write one equation, okay, so what does this represent? This is methane, this is oxygen, this is carbon dioxide, and this is water. Okay, so basically what you mean by stoichiometry is whatever number is written in front of the molecule is stoichiometry. Easy? Okay, this is stoichiometry. So we'll be doing some problems. Before that, I need to tell you something else. In the last equation which I wrote, I'll write once again, CH4 plus 2O2 gives CO2 plus 2H2O. So in this, for stoichiometry, you have to remember one thing. Last class we studied about moles. Okay, now we have to equate moles with grams. So last class I told you something that 1 mole, any compound, will contain the molar mass of that particular compound. For example, if I say 1 mole, like MOLE is full and short form is MOL. So if I write 1 mole of C, like 1 mole of carbon, 1 mole of carbon is equal to 12 grams of carbon. This 12 gram is the molar mass of carbon. If I say 1 mole of oxygen, if I write only O, then it will be equal to, what is the molar mass of oxygen? 16 grams of O. 16 is the molar mass. If I write 1 mole of H2O, 1 mole of H2O, 1 mole of H2O will be equal to molar mass of H2O. Now, what is the molar mass of H2O? Remember last time we calculated 2 into mass of hydrogen plus 1 into mass of oxygen. That is equal to 2 into 1 plus 1 into 16. That is equal to 18. So 1 mole of H2O is equal to 18 grams of H2O. Okay? If I write 1 mole of O2. Now, how many oxygens are there? 2. And what is the molar mass of 1 oxygen? 16. So that means 1 mole of O2 will be equal to 32 grams of O2. Okay, this is easy. So now we can proceed to our topic. I wrote this equation. Now, this stoichiometry, we have to connect stoichiometry to the number of moles. This means that if 1 is written over here, it means I have 1 mole of CH4. Next, 2, I have 2 moles of oxygen. Then I have 1. I have 1 mole of CO2. And last, I have 2 moles of water. Now, I told you that have to connect this 1 mole with molar mass. So let's calculate molar mass of CH4. CH4 means 1 into, what is the mass of carbon? 12. I write 1 into mass of carbon plus how many hydrogens? 4. 4 into mass of hydrogen. That's equal to, what is the mass of carbon? It's 12 plus 4 into, what is the mass of hydrogen? 1. So 12 plus 4. That is equal to 16 grams per mole. It's the molar mass of CH4. Okay, so 1 mole of CH4 is equal to 16 grams CH4. Okay, now O2. O2. 2 into mass of oxygen. 2. What is the mass of oxygen? 16. So 2 into 16 is 32 grams per mole. This is the molar mass of O2. So, now I will 32, right? 32 grams of O2. Okay, now next is carbon dioxide. CO2. 1 into mass of carbon plus 2 into mass of oxygen. 1 into, what is the mass of carbon? 12. 2 into, what is the mass of oxygen? 16. Now 12 plus 32 will be equal to 44 gram per mole. 44 gram per mole is the molar mass of CO2. So here I can write 44 gram of CO2. Next is water. I already calculated 1 into, so the 2 hydrogens, 2 into mass of 1 hydrogen plus 1 into mass of 1 oxygen. That's equal to 2 into 1 plus 1 into 16. That's equal to 2 plus 16, which is equal to 18 gram per mole. 18 gram per mole is the molar mass of water. So now here you can write 18 gram of water. But forgot one thing. You have 2 moles of water, right? So 32 is the mass of O2. This is for 1 mole. This 18 of water is for 1 mole. So how many moles do we need? We need for 2 moles. If 1 mole of oxygen, the mass of 1 mole of oxygen is equal to 32 grams, then 2 moles will be equal to 64 grams of O2. Now, if 1 mole of water weighs 18 grams, then 2 moles of water will weigh 36 grams of water. Okay? Now you understood how to relate moles with 16 grams. Okay? Next one is something called molar volume. Okay, now what do you mean by molar volume? It's simply the volume occupied by 1 mole of a substance. The volume occupied by 1 mole of a substance is known as molar volume. Now, 1 mole will occupy 22.7 liters. In NCERT it's written 22.7, but if you search in the net it's given 22.4. You need to follow what is written in the book. Okay, so 1 mole of any substance occupies 22.7 liters of space or volume. Okay, now we will relate this over here. Instead of 32, I can write 64. Instead of 18, I can write 36. Now, I told you 1 mole of any substance occupies 22.7 liters of water. Then 2 moles of O2. No, but it's 20. If 1 mole occupies 20.7, then 2 moles will be equal to. Multiply this, what do you get? So it's 0.5.4. Similarly, it's 1 mole over here. It will occupy 22.7 liters. Here it's 2 moles will occupy 45.4 liters of water. Okay, now the next thing is now we'll do problems so that you understand this topic better. So it's problem 1.3 from the book. The question is calculate the amount of water. Calculate the amount of water in grams produced by the combustion of 16 grams of methane. Okay, so calculate the amount of water produced on combustion of 16 grams of methane. So it's very easy. First of all, you have to know the equation. We studied it just now. Okay, so this is our equation. Now, we have to write it in terms of moles. 1 mole of CH4 reacts with 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of water. Okay, now I also wrote 1 mole of CH4 is equal to what? 16 grams of CH4. 16 grams of CH4 will react with 64 grams of oxygen to give 44 grams of carbon dioxide and 36 grams of water. So from this, we'll write next equation. Now, what would that be? According to our question, it's given. We have to find amount of water. So we need to calculate water by the combustion of 16 grams of methane. So we are concerned about methane, concerned about water. So first we need to know, according to our balanced chemical equation, okay, according to our balanced chemical equation, the amount of methane produced. Now, 16 grams of methane produces 36 grams of water. So write this down. 16 grams of CH4 produces 36 grams of water. Now, According to our question, what we need, calculate the amount of water is produced by 16 grams of methane. Now, how much is 16 grams of methane producing? 36 grams of water. So, what is our final answer? Our final answer is 36 grams of water is our answer. Right? This was easy. Now we'll do the next question. Our next question is problem 1.4 in the book. Now, what is this? How many moles of methane are required? How many moles of methane are required to produce 22 grams of carbon dioxide after combustion? Okay, we have to find number of moles of methane required to produce 22 grams of carbon dioxide. What was our first step? Our first step was to write down the equation, which is CH4 plus 2O2 gives CO2 plus 2 moles of water. Now we have to write number of moles, 1 mole of CH4, 2 moles of oxygen, 1 mole of carbon dioxide, and 2 moles of water. Now, what is given in the question? 22 grams of CO2 is given in the question. So I'll convert all these moles into grams. So do you remember the molar mass of CH4? 16 grams. Oxygen, 64 grams. Carbon dioxide, 44 grams. And 2 moles of water is equal to 36 grams. Now, according to our question, what we need to produce? We need to produce 22 grams of carbon dioxide. So I'll write it. We need methane and we need carbon dioxide. Carbon dioxide is here, methane is here. So we're not concerned about the rest of the reactants. We are only concerned about methane and carbon dioxide. So what we need to produce 22 grams of carbon dioxide. What we need to find number of moles of methane. So whatever we need to find, we must write it on the right hand side, and whatever is given, we need to write it on the left hand side. So here, what is given, carbon dioxide is given, we write this on the left hand side. 22 grams of carbon dioxide is produced by, this is the LHS, what is the RHS? You have to find it. Produced by, now see this. Sorry, I wrote it mistakenly. It's not 22. It is 44. Okay? So 44 grams of carbon dioxide is produced by 16 grams of methane. Okay? 44 grams of carbon dioxide is produced by 16 grams of methane. Now, you remember the unitary method, right? What is the unitary method? Like if I tell you Is 2 oranges cost 10 rupees. Then, what is the cost of 10 oranges? So, how will you find it? It's very easy. If 2 costs 10, then 1 would cost 10 by 2. That is equal to 5. Then what is the cost of 10? We need to multiply this value with 10 and get 50 rupees. Okay? So, similarly, if 44 gram of CO2 is produced by 16 gram of methane, then 1 gram of CO2 is produced by 16 divided by 44 gram of methane. Okay? Now, next, how much do we have to find? We have to find 22 gram carbon dioxide. So, alright, 22 gram of carbon dioxide is produced by 16 divided by 44 into 22 gram of CH4. Now, what is this equal to? We can 2, 8. 8 gram of CH4. But what is the question? Going to our question, we need to find the number of moles. Okay, so what did we get? We got the number of grams. We need to convert it into moles. So in the last class, I told you an equation. Number of moles N is given mass by molar mass. In short form, you can write number of moles is equal to given mass by molar mass. So now we need to find number of moles. So how will we do it? The given mass is 8. The molar mass of CH4 is 16, already calculated. 1 by 2, that is equal to 0.5 moles of CH4. This is our final answer. Okay, this was easy. I'll give you another question. Now, the next question is, calculate the amount of H2O2. Calculate the amount of H2O2. Okay, this is, we have to calculate the number of moles H2O2 produced by the reaction of 4 gram of 4 gram of hydrogen. Okay, you need to calculate the amount of hydrogen produced. Sorry, you need to calculate the amount of H2O2 in moles by reaction of 4 gram of hydrogen. So how will you do this? First, we need to write the reaction. H2 plus O2 gives H2O2. Do you know what's H2O2? This is hydrogen peroxide. Okay, now then we need to write number of moles. 1 mole of H2 reacts with 1 mole of O2 to get 1 mole of H2O2. Next step, we write number of mass. 2 hydrogen, 1 hydrogen is 1 gram. 2 hydrogen is 2 grams. 2 grams of hydrogen. Now, 1 oxygen is 16 grams. 2 oxygen is 32 grams. Now, calculate this. H2O2. 2 into mass of hydrogen plus 2 into mass of oxygen. 2 plus 6 and 2 is 32. That is equal to 34 grams. This will be equal to 34 grams. Now, what is our question? According to our question, we need to calculate the number of moles produced by combustion of 4 grams of hydrogen. So, first we'll write 2 grams of hydrogen produces 34 grams of hydrogen peroxide. Now, how much is given in our question? It's 4 grams. First, we'll write 1 gram of H2 produces 34 by 2 grams of H2O2. 4 grams. According to our question, we need to calculate 4 grams. So 4 grams of H2 produces 4 by 2 into 4 grams of H2O2. This is equal to 68 grams of H2O2. Easy? Okay. Now, the next topic is limiting reagents. Okay, so what do you mean by limiting reagents? I'll write down the definition. The reactant which gets consumed and limits the amount limits the amount of product formed is called limiting reagent. Okay, the reactant which is consumed and limits the amount of product form is called limiting reagent. So, for example, if I need to explain this in simple terms, suppose you're baking a cake. Suppose you're baking a cake, okay? So, and you require 1 kg flour and you need 8 eggs. This combination will produce 1 kg of cake. Suppose you open the fridge and you're taking out the eggs. 4 eggs fall down, break. So now you're left with only 4 eggs, but you still have 1 kg flour, right? Now, what do you do? So, will you be able to bake 1 kg of cake? No, you won't be. Because for 1 kg, even though you have 1 kg of flour, but you need 8 eggs for it. But since you have only half of the eggs, so you can only take half kg. You can only take half kg flour. You can only take half kg of flour with 4 eggs. And what will be the result? See, this particular component became half. So even though this is an excess, but this also you can take only half. So how much cake would be produced? It will also be half. Understood? So from this, what can you know about the limiting reagent? So this particular thing, this particular component becomes the limiting reagent. How? This is the limiting reagent because since we didn't have the amount of eggs which we were supposed to have, this was lagging. We didn't have 8 eggs. We required 8 eggs, but we didn't have 8 eggs. We had only 4. Okay, so with these 4 eggs, we were able to make only half kg of cake. So because of lack of this component, our product also got reduced. So the component, okay, see the definition once again. The reactant which gets consumed and limits the amount of product formed is called limiting reagent. This particular reaction, in this particular reaction, because of the eggs, because of the lack of eggs, we could only bake half kg of cake. So in this particular case, the number of eggs or the eggs become the limiting reagent. Now we'll study it with an example. It's problem 1.5 from the book. Okay, we have 50 kg of nitrogen. We have 10 kg of hydrogen. These two are mixed to produce ammonia. Okay, first we need to calculate the amount of ammonia formed using these reagents. Okay, now second, we need to find the limiting reagent. So if you remember, first thing, to find out the amount of product, first we need to know what is the limiting reagent. So our first step will be to calculate the limiting reagent, and the second is to calculate the amount of ammonia formed. Okay, so how do we calculate the limiting reagent? First, we need to know the reaction. The reaction is N2 plus H2 gives ammonia. First, we balance this. This is balanced chemical equation. Now, we have 50 kg of N2 and 10 kg of H2. So, our first step is to calculate number of moles. Okay, so what is the formula of number of moles? Given mass by molar mass. The given mass should be in grams. first we'll calculate number of moles of N2. What is the given mass? 50 kg. I'll convert it into grams. Given mass with mole mass of nitrogen. Mass of 1 nitrogen is 14. Mass of 2 nitrogen is 14 into 2, that's equal to 28. So this should be divided by 28. So approximately, I'm telling you, approximately, my answer will be 1786 moles. These are approximate numbers. Next, we need to calculate the number of moles of hydrogen. Number of moles of hydrogen is equal to given mass 10 into 1000 divided by 2. Okay, so what is the approximate value? Not approximate, it will be equal to 5000, right? Moles. Now, what is the next step? Now we need to consider this reaction. According to this reaction, I write it in another board. N2 plus 3H2 gives 2NH3. So 1 mole of nitrogen reacts with 3 moles of hydrogen to give 2 moles of ammonia. So how do we calculate the limiting reagent? One mole of nitrogen requires 3 moles of hydrogen, right? According to this equation, we get 1 mole of N2 requires 3 moles of hydrogen. Okay? So, according to our equation, what do we get? How much nitrogen is present? 1786. So, 1786 moles of nitrogen requires, if 1 requires 3, then this amount requires 3 into 1786 moles of hydrogen. Okay? This is equal to 5,358 moles of hydrogen. So what does this tell you? This says that if 1 mole of nitrogen requires 3 moles of hydrogen, then this much moles of N2 require 5,358 moles of Hydrogen. We require this much amount. But do we actually have this much amount? Do we have this much amount? No. We have only 5,000. We need 5,358, but we have only 5,000. So therefore, hydrogen is the limiting reagent. Understood? I'll tell you once more. We have 1,786 moles of nitrogen. So for that, we require 5,358 moles of hydrogen. But we have only 5,000. So the one which limits the reaction is the limiting reagent. So we got one part of the question. What is that? Determine the limiting reagent. Now, what is the second part? The second part of the question is we have to calculate the amount of ammonia formed. Now, how do we calculate the amount of ammonia formed? Now, since we found out the limiting reagent, let's say now, like this, our limiting reagent was eggs. So now the number of eggs will determine the amount of cake to be baked, right? So according to our equation, this is our equation, right? According to our equation, 3 moles of H2 are required to produce 2 moles of NH3, right? 1 mole of H2 would produce 2 by 3 mole of ammonia. Now, what is the amount or number of moles of hydrogen we have? 500. So, sorry, not 500, 5,000. 5,000 moles of hydrogen will produce what? 2 by 3 into 5,000, right? This will be equal to 3,333 approximately number of moles of ammonia, right? So we need to calculate the amount. Amount means in grams. So how do we calculate the amount in grams? How do we do it? See, what is the mass of ammonia? Mass of nitrogen is 14, and we have 3 hydrogens. So 14 plus 3 is 17 grams. Number of moles is equal to given mass by molar mass. We have